We are doing Honors Algebra 2 Pre-Calc section 6.3, which is vectors in a plane. So let's talk about a little bit of vocab first. This is our introductory lesson. So a vector is fundamentally a directed line segment, right? So if you think about what you know from geometry, a vector is sort of like a ray, right? It has an endpoint, right? And actually we call this the initial point, right? But it has a point, right? And then it has a direction, and it goes to a head that's an arrow, right? So it looks like a ray, and we call this the terminal point. I can spell. Okay, we call that the terminal point, right? So if I were to call this point, let's say P, and this terminal point, let's say Q, there are a bunch of different ways to name this vector, right? So the easiest way to name it is PQ with this little vector symbol over it, right? Notice that the closed dot is over the P because that was the initial point where there's a closed dot, and the arrow is over the Q because again the arrow is on top of the Q, that's the terminal point. Now if I wanted to talk about the exact opposite vector, the vector that started at Q and ended at P, I would call it vector QP, but the point would be here and the arrow would be here, right? So that'd be vector QP. So that's one way to name a vector. Now let's talk a little bit about the magnitude of a vector, right? So magnitude of a vector is denoted, so this is magnitude, right? So a vector is a quantity that has both a magnitude, which is literally a size, right? That's the size, and also a direction, right? So this vector goes this way, right? This other vector that I could draw like this is not the same vector, even if it's the same physical length. It might have the same magnitude as PQ, but it's not the same direction. So a vector is both magnitude and direction. So these two, while the same size, don't have the same direction, right? So PQ might have the same magnitude as, let's say, AB. They might be physically the same size, but they don't have the same direction. And I could draw some other vector that has the same direction as PQ. Let's just call it CD, right? That has the same direction as PQ, but you can see very clearly they don't have the same size, right? So a vector is both magnitude, which is size, and also direction, right? So when we find the magnitude of a vector, if the vector is between 2 points, right? So I'm going to call this point P1, comma P2, meaning point P has an X and a Y coordinate, right? And I'm going to call the Q, Q1, and Q2, meaning point Q has an X and a Y coordinate, right? If I wanted to find the magnitude of PQ, the way that I'm going to write that magnitude is that it is this weird like double absolute value thing, right? It looks like a double absolute value of PQ, right? But really all that is finding the distance formula from Q1 to P1 and from Q2 to P2. So essentially what I'm doing is Pythagorean Theorem, right? This is going to be the square root of Q1 minus P1, quantity squared, plus Q2 minus P2, quantity squared. Because again, if you picture what these sides would look like if I made them a right triangle, this side would definitely be Q1 minus P1, right? It would be the X coordinate minus the X coordinate. And this vertical side would be the Y coordinate, Q2, minus the other Y coordinate, which was P2. So this is my leg squared plus my other leg squared in a square root. Notice that the magnitude of a vector is positive, right? So essentially it's the distance formula that you know from Algebra 2 and Algebra 1, but the magnitude of a vector is positive, right? That's its size. Its size can't be negative, and its direction is which way it's angled, and we'll talk more about direction moving forward later. So another way that you'll see, there's a couple other ways to write vectors, right? Another way that you'll see a vector in your textbook is with a, so vectors are sometimes, so vector notations, right? Vector notations. So there's a couple ways to write vectors, right? So one of them is this way that we just saw here, right? I could write that it's the vector from point P to point Q, right? That's fine, right? So this is saying from initial point P to terminal point Q, and that's fine. Now, another way to write it is in what we call standard position, and we're going to talk about that more in another video. But if we want to write something as just a vector v, we can. When we write it as just vector v, there are two ways to write this. In a textbook, you're going to see this as a bolded v. Okay, so in a book, this is going to be a bold v. Bold, lowercase v. But the problem is that realistically for us, that doesn't make a lot of sense when you're handwriting things. Like it's awkward to sit and bold a letter by just writing and writing and writing. So when we write it, we'll probably write it as a V with a little arrow over it, right? So this is the same thing. This is the same idea, but by hand, right? So these are the same notation But when you see the bolded lowercase v, it's usually in a textbook, right? And when you see it with a v and a little arrow above it, that's usually something you've written by hand because it's awkward to bold things by hand. Now, in both of these cases, okay, these are going to be vectors that we call standard position, right? So vectors in standard position. And we're going to talk about that in our next video. But essentially, well, you know what, I'm going to cheat and talk about it a little bit now, and then I'll throw in the next video too. So essentially, standard position means that the initial point is at the origin. Is at 0, 0, the origin of our Cartesian coordinates. So what we're going to do in the next video is we're going to show, I'll show you the same vector in two different positions, and we'll talk about why they're the same vector and how they're really just moved to a different location. Because again, a vector is two things. It's a magnitude, meaning a size, and a direction. It doesn't matter physically where you position the vector, and that's what we're going to do in our next video.